Hello and welcome to Buildings of Tomorrow. My name is John Lester, and in this episode we're talking about hydronic circuits and the most important hydronic circuits for us in the industry today. I'm joined in the studio today by Chris Kopp. He is an expert in hydronic theory and HVAC theory. Chris, thank you for joining us.
My pleasure, John.
Today I'd like to talk about hydronic circuits and what do we see today? What are the most important hydronic circuits in the industry today?
When we look at the different hydronic circuits, we basically or traditionally have 6 different setups, meaning 6 different ways to construct the piping network to serve different consumers. Out of these 6 today, there are 2 which we don't want to use any longer, at least in new setups, because they are not very energy efficient. The reason is they pump a lot of water throughout the building without any benefit to the consumers, but with a lot of losses and the pump that's constantly running. So we would like to stay away from that and rather focus on the other 4. Right. And these 4 are, first of all, the mixing circuit, which is widely used in room heating systems, in residential buildings, in commercial buildings. And the reason why they are called mixing circuits is because they take warm water from the supply side and mix cold water from the return side together in order to first lower the temperature and also reduce the temperature spread between supply and return across the consumer in order to adjust the capacity, because we need to match the demand of the consumer with what we provide.
And that mixing of demand, or the mixing of the water to reach the perfect level of demand, I assume that this would have a big impact on the energy efficiency of the system.
Yes. So when we look at these mixing circuits, they are set up in a way that we constantly run a certain amount of water across the consumer. And to adjust the capacity, we play with the temperature difference.
Okay.
With respect to the production side, where they get the warm water, they are efficient because they only receive as much water as they actually need at any given time. And the mixing circuit is doing that itself because the internal pump is designed in a way that it pulls the right amount of water from the production side. But of course, in order to do that, the distances between this mixing circuit and the production shouldn't be too far. So this only works if the circuit is rather close to the main supply lines or to the production side.
So you'd find certain buildings that lean themselves to one of these solutions.
Yes.
Because of the physical layout of that building.
Exactly. So as I said before, typically in residential buildings, you have the boiler in the same room as these distribution circuits. So it's only a few meters in between. And then the pump is able to get the right amount of water by itself.
And you mentioned earlier energy efficiency. Is the hydronic system, is the hydronic circuit a large consumer of energy within the building?
I wouldn't say a large consumer, but it plays a very vital role in running a building energy efficient. And the main focus we have today is we would like to make sure that from the supply side, from the producer to the consumers, we only transport as much water as is actually needed. And that reduces the pumping power, and it also reduces the heat losses or heat gains in case of a cold water network. And besides the mixing circuit, we also have an injection circuit, which again mixes 2 water streams, but now the pump in the inner circle is not able to get the water by itself because the distance is way too far to the producer, and there we need an additional pump that supplies then the water from the production to this injection point, as we call it, in this inner circle. And again, there we mixed the 2 circuits together.
So a similar theory, but because of the distances,
Exactly.
You have to have a different approach.
Right. And then the last way to do that, which we prefer today, is doing it with what we call a throttling circuit, which is variable flow across the consumer and also variable flow between the production and the consumer. So we have variable flow throughout the whole system. And there are even people in the industry that say that's the only way we want to do that now and in the future, which might be a little bit radical, but the people I know who do that, they're very successful and it's very energy efficient.
Okay, is from from the outside in, it makes sense. You across the entire system, you only provide the exact amount of energy that's required. It has to be the way to do it with the least energy loss.
Exactly.
Perfect.
Exactly.
Thank you very much for your time.
My pleasure. Thank you.
And thank you all for joining us on Buildings of Tomorrow. Feel free to like, comment, and share this episode, and please subscribe to us here on this channel. Thank you for joining us.